Okay, welcome back. So we're looking at past questions on particle nature of matter and crystal structures. So let's begin. Okay, so the first question we have says, which of the following statements about matter is correct? A. Molecules of solid move freely than molecules of liquids and gases. B. Molecules of solids are more closely packed than those of liquids. Energy is required to break the intermolecular bond or intermolecular forces of attraction between molecules. D. Molecules of liquid move about within the liquid and they are in constant motion. The obvious wrong answer here is molecules of solid moves more freely than molecules of liquid and gases, and that's the answer to this question because we're asked which of the statements is not correct. So A is not correct. Of course, molecules of solid move the least among liquids and gases, so you can't say molecules of solids moves more. So 2, list 3 phenomena which can be explained by the molecular theory of matter. All right, so we have Brownian motion, we have diffusion, we have osmosis, we have surface tension, we have capillarity. Of course, surface tension, capillarity, we're yet to do that, so we'll do that in coming classes, but at least we know Brownian motion for now, we know diffusion and osmosis. So osmosis is basically a type of diffusion where you have solvents pass through a semi-permeable membrane from a more concentrated place to a less concentrated place. Okay, so that's osmosis. We'll still get to that in future class, but so 3 of them you can list now. We can take Brownian motion, we can take diffusion, we can take osmosis. Okay, because osmosis is a type of diffusion. So but these 3 phenomena can explain molecular theory of matter. Which of the following statements about the molecules of solids and liquid is correct? They both A. have weak attraction, B. have wide separation, C. exhibit random motion, D. exhibit vibratory motion. So our answer here would be D. They exhibit vibratory motion. So our answer will be D. Okay, because solids don't have weak attraction. Okay, solids don't have wide separation, and solid does not exhibit random motion. Okay, so solid molecules don't do all these 3, but they can exhibit vibratory motion. Liquid molecules can also exhibit vibratory motion. So number 5, which of the following statements best describes the particles in a solid at room temperature? A. Far apart and randomly moving. B. Close together and vibrating close together. C. Close together and stationary. D. Close together and moving randomly. So our answer here will be B. Close together and vibrating close to each other. Alright, that's what looks more ideal for solid at room temperature. They can't be far apart and randomly moving. They can't be close together and stationary. Okay, they can't be close together and moving randomly. They can't be stationary and they can't be moving randomly. So number 6, which of the following particles are termed nucleons in a neutral atom? A. Protons and neutrons. B. Neutrons and electrons. C. Protons and electrons. D. Protons, electrons and neutrons. Okay, our answer is A. Protons and neutrons. They make up the nucleus. Alright, electrons are not there at all. Okay, so 7. So which of the following statements is not correct? A. Molecules of a liquid are stationary. B. Brownian motion is an evidence of particle nature of matter. C. Matter is made up of molecules. D. The molecules of matter are in constant motion. A should be the one that is not correct because molecules of liquid are not stationary. Alright, so A should be the right answer. Okay, number 8. In an experiment in which a molten substance is allowed to cool, the cooling curve above was obtained. The temperature 60 degrees Celsius is known as the A. vaporization point. Okay, cooling temperatures, boiling point, melting point. Of course, this is the melting point. Okay, so we talked about this curve when we talked about the anomalous expansion of water. So we talked about this curve when we talked about crystal structures and non-crystalline structures. Okay, so at this point you have change of state happening here. Okay, so this is the melting point. This is the melting point of your crystal structure. Okay, number 9. The motion of smoke particles from a chimney is typical of A. Random motion, B. Circular motion, C. Rotational motion, D. Oscillatory motion. Of course, the answer there is A. Random motion. So number 10, change of state, diffusion, radiation, osmosis. Which of these processes above can be explained using the kinetic theory? Of course, we can do that for all except radiation. We can explain that with change of state, diffusion, osmosis. So we have 1, 2, 4. That would be B. B is our answer here. Which of the following statements is not true about atoms? An atom is made up of a nucleus and a number of electrons. B. The mass of an atom is concentrated in the nucleus. C. Atoms of different elements have different atomic weights. D. Atoms of all elements are identical. Okay, so D happens to be false. So D is the answer. Atoms of all elements are usually not identical. So number 12. It is a rapid, constant, and irregular motion of tiny particles. 2. It gives evidence that tiny particles of matter called molecules exist. 3. It takes place only in gases. 4. It gives evidence that molecules are in a constant state of random motion. Which of the combination above is correct about Brownian motion? 3. It takes place only in gases. Oh no, 3 is not correct. Brownian motion doesn't take place in only gases. So we have 1, 2, 4 to be our correct answer, which is D. 1, 2, 4. Alright, so that's the much you can take for today. See you guys in the next class.